Flip back up, so Pete and Karen, how did you put their energy review process together?
We're gonna put it all on Jeff.
So Jeff's assigned the responsibility. Did you list the steps?
For Jeff, yeah,
What did you put? Do you have it written down?
yeah, weight section down there, we wanted him to.
Oh, yeah, that's right, you guys are again.
Yeah. Oh, yeah. So, we at least wanted him to talk to the folks who are in charge of those 3 or 4 areas we already identified as SEUs, to make sure that the processes were similar, or conditions hadn't changed a whole lot, or later on in the second part, we actually talked about potential staff changes.
Yeah,
We'll trigger. So yeah, so it's like,
We'll get to
okay,
that.
and make sure that he's interacting with the appropriate people, because they're not gonna just funnel him information on a daily or monthly basis. So.
Yeah, it's really a two-way street, isn't it? And I like your thinking. We've identified these SEUs, so maybe they might be important here for us to keep an eye on, in a sense, that these could have an impact on us. So what else? Did you have your steps listed here? I called on your team when you were out. Left Pete with no problem.
Yeah, for the process, the first we want to determine, like, we are going to do the update energy review annually, and the second we want delegate a person who is, they should actually, that be responsible for updating the energy.
And that was Jeff.
Can be there or something like this. And what else? And I think.
Yeah, I mentioned the next one as far as interacting with the major energy users. Assuming there needs to be some closing the feedback loop in terms of with upper management. I don't know if that's really covered later under the management review specifically.
Yeah.
Or should be part of this.
Probably.
Spelled out in here too.
I mean, some people develop their management system so that if this was a formal procedure, they could require the procedure that the update be signed off by top management. That's really putting a noose around your neck in the sense that, just depending on the organizational structure, is that something that management, does the president need to approve every purchase order? You don't necessarily need to create that kind of detail. It's the standard doesn't require it. It's up to the organization to put in a process that works for them. What we do when we're coaching the company is we just start asking the questions: what are your energy sources? Where's the data? How do you do the analysis? Where's that? Where's the record of your analysis of use and consumption and so forth? And then we just sit down in this process and say, okay, what do we do and where do we go? We write these steps out. And then we ask them, how do you want to, for lack of a better word, institutionalize that? Do you want to make a formal procedure, or do you just want a checklist of items on a spreadsheet? When you go to collect this data, and we go through this checklist, or, and we kind of sit down after the fact, but this is the first time through. The 3M tool that I was bragging about in their corporate procedure, really I have to give credit to Cummins, because Cummins had developed a corporate spreadsheet for the energy review. And they shared that with 3M. They were in a cohort together. And 3M then took it and really finished it and made it a lot more thorough in its process. And coupled with that was they put a corporate procedure in for how they do all this. So,
so in our case, like the NS championship would be the person updating the energy review as well, but we did put a process together to identify when we need to do it. So what we thought of was a cross-functional energy team, like across the facilities. So one guy from procurement, one guy from maintenance, one guy
to work on the update.
not to work on the update, but to meet together with Jeff on a monthly basis, could be 2 months once, and then they talk about what are the stuff they did differently. Say, we didn't buy natural gas vehicles, instead we bought, there'll be an update from procurement there. And Jeff will decide, okay, this needs to go into the energy, this will need to go. So yeah, so that.
So you're basically saying that the update came out of an energy team meeting that might be monthly or bi-monthly,
And Jeff will decide this needs to, this triggers energy updates.
So would that work? You guys, would that satisfy the requirements? for the
Well, you
state?
still need a defined interval. So as long as you're doing that and barring nothing, you still did there.
Yeah,
Yeah.
this is a good.
So did you have a defined interval in your procedure?
So for the energy meeting?
Well,
For the review.
for the review.
So an annual review, I think, would be there. In addition to this, like to find the triggers, this would be a monthly thing or bi-monthly.
Right, because we hadn't, the other part, you do need to define what the interval is, quarterly, yearly, monthly, whatever.
So the meetings are just to find the triggers, additional.
Right, so what you're really describing are the changes, the significant changes, or the major changes, I think the standard says. A lot of times that's done by saying anything that could impact our consumption by plus or minus 5% or 10% or something. That's a major change. And they'll define a major change in some kind of quantitative terms like that. But it also could just be the energy team meets and decides when a major change has occurred. There's nothing in the standard that says that's not appropriate. So that would work as well for the major change. But you need to define that interval and what is a major change. So what are the major changes that could trigger an update for KRM? Any and everybody, what did you list?
First, we focus on the products, like currently they have slurry and dry powder. If the moisture content changes because the market or the client, asks to changes, major changes on the moisture content in the product, it's going to be changed. And maybe we have a new product, like the moisture content is kind of in between of slurry and dry powder. And the raw material, like the lime, and then the iron, the impurity has changed.
Yeah, we say moisture level here, but really what's interesting about kaolin is 50 years ago, this industry was dead because there's no more recoverable kaolin. I don't know who the first guy to do this was, but you know what a superconducting magnet is? They take an electromagnet, put the coil in liquid helium, and now it has this, you can get these very intense magnetic fields with very low current. And so they can run the kaolin through that, and it pulls out all the iron, which is a staining. It creates this brown stain. They're paid for the brightness or the whiteness of it. So now there were, square miles of recoverable kaolin that was once unusable. The other thing they use it for is interesting. There's a plant not far from my house. It makes proppants, which you might find this interesting. Angie, I don't know if you've ever heard that term, but they pump those down into fracked structure to hold to make a porous substrate for the gas to flow through. So they take kaolin that's not usable in other forms to make little ceramic beads, I think gajillions, and that becomes this porous material, or like sand, if you think about it, they can fill those fractures with, so that because what happens is that as the fractures close, or the earth moves, and the well quits producing, so these proppants hold it open. And they use kaolin for that. Certainly the end product, you guys talked about looking at process changes or energy sources. I like that. That was good. What about disasters? Did anybody think about that as a scenario? That never happens to industry, right? I tried to get to, I don't know why I had to go to Kokomo so many times for Chrysler, but the first time I was supposed to go, I got snowed out by a blizzard. And then the next time I went, a tornado actually hit the plant. So it tore a corner of the plant off. All the transmissions for Chrysler are made within 10 miles of Kokomo, Indiana.
Guess they weren't inviting you back.
I don't think they associate me with the weather, thank goodness. Anything else? Did y'all have something else?
I think we mentioned
Yeah,
about
we
staff
have staff
changes.
changes.
Yeah.
Staff changes.
Staff changes on the, especially.
Your
more
SEUs.
responsible SEUs, yeah.
I think one additional thing that we had was changes to procurement, like say, because there was a couple of recommendations where they were gonna shut off the main natural gas pumps and something like that. So if something like that changes the procurement.
Well, you know, think about the, I guess,
Energy sources.
you remember that one opportunity with the flocculant for the vacuum filtration, which had a big impact on the spray dryers. I guess that would be a process change.
Yeah.
But it would be very easy for something like that to get done. Somebody might do that, even just improve the vacuum filtration and not even recognize that now the spray dryers have been impacted.
Yeah.
And maybe we need to think about, All right. Any other questions or comments on that?
So a general comment, Randy, with regards to like the energy team, in ISO 50001, like there is a provision in top management that says like the top management should encourage formation or allow for the formation of energy teams. Is there any other criteria for energy teams in ISO?
You'll find out when we look at the scorecard on Thursday that there are scorecard points for having a well-balanced energy team. So in my experience, the energy teams, the energy manager, somebody from maintenance, maybe somebody from production, but procurement really ought to be on the energy team, and somebody from facilities design, or, and depending on your operations, you may need different people. So we looked at, and this was a long module, going back to yesterday about right before lunch. What is the energy review? How's it implemented? That's what we spent most of the time talking about. And then this morning we finished up talking about what we need to do to maintain it. It's the data intensive piece. Where does it come from? How do we manage it? And we don't spend a lot of time in the CP class talking about documentation and records. But you have to have the control mechanisms in place, and a lot of the records for an energy management system come from the data review. Utility bill is a record. The energy review that you do is a record. We talked about the importance of our SEUs and how they're really key to a lot of other pieces of implementation. Deanne talked about relevant variables yesterday, and we looked at the payback versus other financial methodologies. So, as the CP, in terms of supporting the implementation of ISO 50001 and SCP, you are the energy review expert. It's your job to help them do that. It's fairly easy to find support for kind of the routine management system pieces like management review, like documentation and record control, document and record control. There is nothing in the other standards quite like the energy review for 50,001. Swap that. So we're still looking at energy planning. You remember when we opened yesterday, I said everything that starts with 4.4 something is energy planning. It's the planning piece of plan, do, check, act. So we just spent basically a full day talking about 4.4.3. And now we're going to look at 4.4.4 and 4.4.5. And actually in the standard, baselines are listed first. Energy performance indicators are listed second. But in my mind, and part of our logic in the way this content is presented is, it's really hard to talk about one without the other. Once you define a performance indicator, how you evaluate that indicator is tied up in what baseline you define for that indicator, right? So the baseline, we'll talk about what those mean. Excuse me. So what we want to look at, and hopefully what you will feel comfortable doing at the end of this, is establishing performance indicators to measure energy performance, what are good ones versus maybe not so appropriate ones, understand the impacts, and have established baselines. And there's two parallel things going on here. We're talking about the requirements of ISO 50001. ANSI MSC 50021, which is the SEP requirements, requires that you develop this SENPI, the Superior Energy Performance Indicator, which is the model, which is the top-down regression analysis that we do on our energy performance. And so we had this requirement for SEP that we have a specific ENPI related to superior energy performance. And then we had the general for 50,001, our energy performance indicator. So KRM has this BTUs or MMBTUs per ton, right? It's a traditional metric. Do you think they're going to abandon that when they adopt superior energy performance? And just say, well, we'll use this SENPI for our new metric. No, they probably won't, because they've got, for the Kellen industry, they might have centuries of legacy and history of understanding their industry through this, ENPI they call MMBTUs per ton. So that's quite often SEP is, this specific ENPI that we're tracking over here for superior energy performance, but there'll be a whole set of ENPIs that the organization manages for their energy performance. If somebody's interested enough to do an energy management system, they already have ENPIs in their organization, or KPIs, as we saw in KRM. I just talked about that, but the other piece of this whole process, again, is sustaining it. So as you move forward in time, baselines become dated, they need to be updated, or the ENPIs might change for all the reasons you suggested in the energy review, right? The process changes, our mix of fuels are changing. What if KRM, what if a large supply of landfill natural gas became available to them at a very low cost? Would that change the way they think about and run their process and manage energy? Yeah, it would, because landfill gas is typically not it's not super high BTU value, and it can be wet and kind of nasty in other regards, but it's very cheap, and it's environmentally, a good thing to use So as we talked about on the first day in our intro to ISO 50001, it does require improvement in energy performance. And in that, I think in the folder that you got off the flash drive yesterday is a resources subfolder. In that resources subfolder is a spreadsheet, I think. No, it's probably PDF. It says terms, occurrence, index. And we'll talk about that more. But if you look at energy performance in the left-hand column, and then you'll see all the places that it occurs in the standard, and the standard is full of places where it says, you know, you have to make a commitment in the policy to improving energy performance. And so it flows from the top all the way down through it, that energy performance is our whole aim in implementing the energy management system. But what do we mean by energy? What is energy performance? What does that mean to us? You know, what is the definition? It might be in the slide, I can't remember.
Includes energy use, energy consumption, energy efficiency.
Somebody's been reading. Somebody read the definition for energy performance.
Measurable results related to energy efficiency, section 3.8, energy use, section 3.118, and energy consumption, 3.7, and then there are 2 notes related to it.
And the notes are relevant for the definitions. The notes are just extra information in the requirements, but they do add to your requirements. Now, one of those notes is about energy sources, figuring into that, right? Am I remembering that one correctly? What are the notes?
In the context of energy management systems, results can be measured against the organization's energy policy, objectives, targets, and other energy performance requirements. That's note 1. Note 2, energy performance is one component of the performance of the energy management system.
So it does say measurable results, right? That's how the definition starts.
Yes.
So we're talking about some kind of quantifiable entity. How do we measure energy performance? Now, it doesn't say how you do that. It's up to the organization to define it. The only prescription for the measurement of energy force you're going to find in energy performance that we're going to talk about is specific to SEP. You know, SEP has a very prescribed methodology for how we define energy performance in the energy protocol. But for 50,001, what makes sense for the organization? And how do we define it? And those notes go on to say, basically, there's a whole really broad set of things that the auditor will consider in the certification process for determining has energy performance improved or not. So think about setting objectives and targets. Have they moved towards those? Are they attaining them? Is the policy supporting and driving, you know, the whole process? And in the end, a lot of performance really boils down to how we choose to define our indicators for this. And you'll talk about your role at the end of this. So this comes from the definition in the standard, right? Energy performance can be determined through our evaluation of energy efficiency, energy consumption, energy use, energy intensity, or even in other ways. Our main point is that and the U.S. position in the ISO negotiations was very strong that we wanted a performance component in this standard. We did not want just a standard that says here's the information that you need to gather, here's how you manage it, and, you know, if you go and look at the quality or environmental standards, you pretty much define what the outcomes are that you want, as long as you say what you're gonna do, and then you do what you say. There's a little bit of a stick in 14,000 because it's tied to your legal compliance requirements and that kind of stuff. But 50,000, it says you have to improve energy performance. There's nothing in 9,000 that says I have to improve my quality performance. I can say I want to make really bad stuff, and yeah, we make really bad stuff and we know it, so therefore I'm 9001 certified. Most people wouldn't survive in a market like that, but the standard itself doesn't require that. 50,001 doesn't give us that option. So the planning process again, these 4 large building blocks, we just talked about that, and we spent a lot of time looking at what the energy review is. Energy performance metrics are those 2 topics in 4.4.4 and 4.4.5. Baselines and ENPIs. So why do we need energy performance metrics? Why do I want to know? And that's a fairly obvious question, I think, for this group. But if you think about the cycle of continuous improvement, planning is supported by our evaluation of where we are, how far we've come, and where we want to go. If you think about the planning process. So think about taking a trip. In Atlanta, I want to go to California. So here's how I'm going to get there. Here's how I'm going to evaluate my progress and so forth. So I have some expectation, and as I move forward, I say, am I, moving in the right direction? Am I getting closer to California? Am I attaining, have I reached the appropriate milestones? If I don't define any of that up front, I could wander all over the place and never get to California, right? The old adage, if you aim at nothing, you'll hit it every time. So metrics help us understand how we're doing. They also give us the support that we need. One of the things I think that's happening in SEP is it's starting to gain credibility from the standpoint that this is a meaningful measure that we can use for other types of validation. What we'd really love to see is for the utilities to get on board and say, that they would tie some incentive in their tariffs or their rates to companies that were SCP certified, because now they can quantify their efforts for energy performance improvement.
Is any
Not that I know of, but Pete might have a better view of that than I do.
We've worked with a handful of utilities as a pilot project last couple of years to help some of their customers through the SCP process. And so it hasn't translated into their providing an incentive. I think it was more of a demonstration to show them how, in fact, this would work. If, in fact, you did want to take that step. We'll see where it goes from here.
So we also then use the feedback side of this. The metrics tell us, are we on target? Are we achieving what we thought? And how good is our decision making? It's accredited to Einstein. I don't know that that's true, but the definition of insanity is what? Anybody heard that comment? Doing the same thing over and over and expect a different result. So the whole point of continuous improvement is we're going to evaluate what we've done and ask the question, what can we do different to get a different outcome? Can we do something different to get a different outcome? And the energy performance indicators the metrics that we have for evaluating our performance are really feeding that from an energy performance perspective. So we can use metrics. For SCP, we measure facility level energy performance. When 3M does this, they take that BTU per pound, which is not coming from SCP, that simple index like KRM uses, and they add it up for all the plants, and then they compare the plants with each other, and they do this kind of organizational evaluation of their energy performance. But we might also have specific metrics for my SEU. So we had you work yesterday on looking at the spray dryer performance. And that could be helpful in managing those SEUs to have some specific ones. How many SEUs, how many performance indicators does the standard require that I have for my SEUs? I'm going to go to the trouble to define it as a significant energy use. What does it say about how I measure its performance? I'll give you the short answer, it doesn't. Just like I don't have to have an objective or a target for my SEUs, I don't have to have a defined ENPI for my SEUs. Now, I think best practice is that you would probably have some performance measure for that SEU, because how do you know that you're managing it appropriately? I told you about the company that picked they had 2 air compressors, they're about 200 horsepower, and their objective or their aim was that they could run the plant with one of those, that they could actually turn the second machine off. They had no meters to measure the energy performance, they had hour meters on the machines. So their ENPI for their SEU was the number of hours that the second machine had to run. And it was kind of an inverse, the higher that was, the worse they were doing. The lower it was, or if they could keep it 0 in a month, then they were meeting their objective for its performance. Which is, that works for as far as 50,000 one is concerned, that's an appropriate ENPI.
Excuse me, for the 50,000 for the SEUs, we still need to have some documentation about SEUs.
It says, if you go back and look at 443B, it says I have to evaluate the performance, the current and expected performance. B says determine current energy performance of the SEU. I'll leave out the long description. And then expected future energy use and consumption. So I have to determine the current performance, but it doesn't tell me I have to do that with an ENPI. I'm not sure how you do it without an ENPI.
So this should be documented, they should document this somewhere.
Well, it should have a record of it. You should be able to say, when you say documented, it doesn't mean I have to have a page in the manual that says this is how we do this. When the auditor comes, he says, how do you determine the current performance of your SEU? And he would ask the operator, he would ask the energy manager, he would ask Jeff, he might ask top management. And if you got the same answer from all three, well, there's a monthly report. We get this graph, like y'all did for the spray dryers. Y'all know what y'all mean.
Yeah.
So you did this graph with spray dryers, and And if all three of those guys say, well, you know, the monthly report from the energy team includes this updated chart of spray dryer intensity, or however they describe it, you know, then that would satisfy the auditor. So to say that you have to have a document or, you know, a procedure in place for every little piece, no, you don't have to do that. What you have to have is a process that it's identifiable and the auditor can see that it's working. But there are other, you know, really good organizations that do this have other performance indicators, or have, I should say, they have performance indicators for other parts of the process or equipment. Typically, these are driven by either their need to control cost or their competitive analysis of a product line or something like that. And we may have some specific performance metrics related to achieving our objectives and targets. Think about it this way: if I set an objective or a target, one of the key considerations for that is how will I know when I've made it? Well, you'll know you've made it because we have this performance indicator that says target is we're going to get to less than 1,000 MMBTUs per ton, and you know now I have something to evaluate and understand how well I'm doing.
Very quick question on the, so when you mean you need to document the energy performance even without even PSO, it would just be energy, an estimated energy consumption on it. What else is acceptable by ISO?
Well, in the end, it's, you know, for certification, it's up to the auditor. If industry practiced and/or the organization, there was no meaningful way to quantify beyond an estimate, and they were consistent in the way they applied an estimate, that would work. So if they took some, let's say you're trying to evaluate your compressor system, you had an hour meter, and you had a log sheet that maybe the maintenance guy they stopped by twice a shift to just check on the compressors, and they wrote down, like on the control panel for a rotary screw machine, there might be a load number that says it's 80% loaded. So they might just log the hours, the shift, what the setting was, it's 80% loaded at this point, you know, in our operation. And you have this log sheet and it's fairly consistent, so they estimate performance at this level. You know, that's not inconsistent with what the standard requires them to do. Now, my guess is as they get more mature, they're going to be dissatisfied with that level of information. I mean, can't we get a meter on this thing so we know for sure what's happening?
Sure. But will the log sheet be considered energy performance, though? It's kind of like a maintenance thing.
Well, no, it could be, yeah. Yeah, well, think about a boiler log sheet, which might have a lot of readings from the boiler, what the steam pressure is, the temperature, the reading might include the stack temperature, the ambient temperature, the setting on the louvers on the combustion air intake. It's at 50%, it's at 80%, it's at 100%. So all of those you could feed into a calculation that says the board's running at 83% efficiency. So the thing is about 50,001 is you don't have to be an expert and you don't have to be mature to be certified. You have to have a management system. The management system says, you know, in the South, where I grew up, we'd say you just wade into this pond. You don't get thrown into the deep end to start with. So wherever you are, that's where you start. And so you may not have it all together. I don't have all the meters I want. I don't have everything that I might have in 10 years from now. Does that mean I can't be 50,001 certified? No, it does not. Now, it may keep me from being SEP certified because I don't have the data quality to develop this model that we're going to look at. But with 50,001, the intent of ISO is that this standard can be implemented anywhere by any size organization under any circumstance, period. So you could take a nonprofit, doing work in a third world country. If they want to analyze their energy performance and manage their energy consumption, they could implement ISO 50001. Maybe harder to think about in a service setting than a production type output setting. It's not likely that that would ever probably have much interest in the service sector. And since transportation is a service, and energy is a very big component of that, so I can assure you Delta is very much concerned about the amount of jet fuel they consume and what it costs them, and what the per passenger mile performance is of that aircraft, that crew. There's that's a whole nother can of worms.
Just to get about that, like, really, is the fuel cost really make a big percentage of the cost?
Delta?
Yeah.
Yeah, it's, I don't know, I grew up just south of Atlanta, and a lot of the folks I knew worked at Delta. There was a lady I knew, and her only job was to pay fuel bills. There were like 5 or 6 people in her department, and all they did all day, every day, 200 something days a year was pay fuel bills for Delta. Just jet fuel, not the power bill. So, I don't know, I'm sure the EIA probably has that statistic on what the percentage of cost is for an airline industry. It's pretty high. But anyway, this is just another way of kind of looking at that same chart. We have performance metrics that we might evaluate at the facility level. The process level, we might look at a shift or a line. This is common, like in the paper industry. There'll be a pulping operation that's feeding a paper machine, and the plant might actually have 2, 3. There's one in Savannah, Georgia that had, if they still do, they had 5 paper machines. Well, these are big, huge, massive. When you say paper machine, it's really a set of systems that are linked together. It goes in as pulp on one end, it comes out as a dried sheet on the other. So they might do performance. What's the energy efficiency for running these products on different paper machines? I have it at that level. Or at the system level. In commercial buildings, they will look at the chilled water system or the hot water system. Industry, maybe the steam system or compressed air system. Or it could be actual equipment specific, and we talked about some examples of those as well. So performance metrics or ENPIs can be very simple. At home, what is your measure of energy performance? How do you evaluate energy performance at your house
Bill.
or apartment?
Our bills.
And what are you looking at to evaluate that?
Monthly
Yes,
comparison.
Same on comparison.
I do too. I look at it's higher this month than it was last month. Well, okay, but how did this July compare to last July?
Yeah.
I do that too. And they give me, the Georgia Power gives me this handy little thing in my bill that I can look at that. I can look back a year and see what it was.
When I really looked at, in the future home, so we kind of separate the lighting from the fridge and the microwave. And
Wow.
I thought it's gonna be cool. So kind of have a separate circuit, so maybe, you know,
Meter
maybe
yourself?
say how much lighting, you know, energy because we can say, you know, use it
For
for
the
this.
different appliances.
Yeah.
Well, in the south, you could take everything in my house and put it in one basket, then take my air conditioner and put it in another. It's the big driver for my electric consumption. But you don't have to get fancy to have performance indicators, right? The standard doesn't say what the NPI is determined by top managers to be appropriate for their operations in the organization. So if they're starting in 50,001 and all they're doing is looking at last month's bill and last year's bill, is that appropriate to NPI? For 50,001, that works. Industry, commercially, you know, there's probably a budget. The budget's typically based on what last year was anyway, so. But some sophisticated ones might actually try to trend it. You know, I tell you, a really powerful tool in energy management is the cumulative sum, or Q sum. So if you took, and you can try this with your home if you want, take the 12 months, the most recent 12 months, and see how that line is trending. So if that line is trending up, then you're consuming more energy. If it's trending down, then you would be consuming less energy. If it's staying flat, then you're doing the field. So usually in industry, if they have any experience at all, they'll use to something a little more complex. So MMBTUs per vehicle or MMBTUs per ton, kilowatts per cooling degree day. Specific, that's just another version of specific energy consumption. We'll talk about that. And this is, we have this for SEP. This is a little more complicated than a complex one, in the sense that you have to do some statistical analysis to get to a linear equation. We're going to talk about that. So here's a chart of consumption and cost. Is that a measure of energy performance? Sure. You'll see that a lot. One of the things I think that is important to remember as a CP is you can run into interesting situations in industry. So you're working with a company, they pick, let's say, they pick their compressed air system as their SEU and they really start trying to improve it. So they get on top of the leaks. The Department of Energy estimates that 20 to 25% of all the air compressor horsepower consumed in the country is just to satisfy leaks. Think about that. A third of all energy in the country is industrial. I don't know what percentage of that is compressed air, but 20 to 25% of that is just from leaks. So they get on top of their leaks. They work running about 800 cubic feet per minute to satisfy the leaks and demand, and they get the leaks reduced, and now the compressor idles back to 600 cubic feet per minute. But an electric motor is not linear. If I were to put a 100 horsepower motor on the floor in here and turn it on, with no load on the shaft, it would consume about 30%, depending on how efficient, maybe 25, maybe as much as 35% of the full load amps to do no work at all. So as the compressor turns down, the drive becomes less efficient. And even though I've reduced my overall kilowatts and my need for compressed air, my power doesn't drop off as much as my supply did. So when I had a lot of leaks, I could make compressed air for 21.3 kilowatts per 100 CFM. But now, if I'm graphing that, it's like, man, that leak program is terrible. It'll become less efficient. Now, if I could actually stop enough leaks, maybe I could turn this machine off, right? Another solution for this would be variable speed drive, which would let you slow that compressor down, and I would maintain this relative efficiency at a lower operating condition. So now I'm making 600 CFM at 21.3 kilowatts per 100 CFM. Now I'm really doing it. But just to take a 100 horsepower motor and run it with a 60 horsepower load, you're going to pay for about 75 horsepower in electricity costs. Once those of you from the mechanical engineering side of the street, you know, if I'm designing a piece of equipment or process, this conveyor, this blower, this whatever the system is, I do some load calculation, and it comes up to 88.3 horsepower I need to turn it. Then I put a safety factor on that at 10%, I'm up to 90, because I can't control that every bearing will always be greased or that everything will work exactly right. And then I get the motor book out that says, well, I can get a 75 or I can get a 100 horsepower motor to run it. So my load's about 90. I put a 100 horsepower motor. But that was to carry the conveyor belt fully loaded, you know, 100 feet long with a ton of coal on it or gravel or whatever. You go out there and watch it operate, probably half the day, there's nothing on it. Or for 25% of the day, there's nothing on it. The motor's running at 50% load. So there's a huge opportunity in industry for getting systems matched with the demand, you know, they need. Because just putting in something as big as it needs to be, might ever need to be, creates a lot of inefficiency when you operate less than that. Yeah. You guys run into that all the time, right? But slowing a motor down, variable frequency drives are a great answer for a lot of those circumstances. But that's what's going on in situations like this. There's another example here. Same thing with chillers. So if I was looking at kilowatts per ton of cooling, or in this case we do coefficient of performance, as I reduced my need for chilled water or improved the system, reduced my chilled water cooling load from 75 to 50%, now my chiller's really oversized. And my coefficient of performance went for 2 points. Does that mean I shouldn't reduce my cooling load? No, it means I should maybe think about a different arrangement of chillers to meet that demand. When Buford built this new pilot train at the Marine Air Station, I have to tell you the story because it's just fascinating to me. You know, the mechanical engineer who was looking at the heating and cooling loads, the building's built for 9 simulators, the server room that would support all that data processing and everything, plus a building full of people and offices. I mean, it's a big complex. So the maximum cooling load on the hottest day, on the coast of South Carolina, I think they figured they needed maybe 1,000 or 1,200 tons of cooling. They put in 2 800-ton chillers. The chillers will only turn down to 50%, so they can stage the compressors and the controls so that they can get 400 tons fairly efficiently out of an 800-ton cooler or chiller. They built the building, they put in 2 simulators, had a few servers, and probably half the offices occupied, and only needed 100 tons of cooling. And they couldn't keep the chillers running because the flow rates were so low and the temperature drops were so minuscule that it would go off on alarm, you know. And they had all kinds of problems because on this side it was designed for this point of operation, but no one ever considered it might not be running at that all the time.
Less than 1/10 of the original the design.
Now a lot of that's probably gone away at this point. I don't know how many simulators they're up to now and what the load on the building is, but you know, we're trying to implement 50,001, and every meeting we have the utility manager, his pager's going off because they got an alarm in the pilot training center down here because of chilled water. the air conditioning was so oversized for the chiller room, for the server room, the computers, that they're having to run reheat to keep moisture from forming in the room. So they were cooling the air and then having to heat it back up so that they weren't sweating, because there wasn't enough load in the room, you know, so you run into all kinds of situations where even when people they will pick efficient chillers, they'll pick efficient equipment, but the optimization has to do with the whole system, not the single piece of equipment. That's just another example of an ENPI you might have on a specific piece of equipment. Simple ratios, we say be wary. Same kind of concept, I can improve the steam system efficiency by insulating lines, returning condensate. Now the boiler turns down and it's not firing at, it's much more efficient for the boiler to be firing close to full load than it is at half load. Same kind of thing. If I reduce my steam pressure, I'll consume less energy, but my actual boiler efficiency will go down. Does that mean you shouldn't reduce the steam pressure? No. Energy intensity is fairly common. We talk about that a lot. We're also hopefully helping you understand that it's not as complete as you might think. For KRM to know the BTUs per ton is helpful, but it doesn't tell them the whole story, right? They can make the wrong assumption about why it's moving in a certain direction. They make decisions based on that assumption, and all of a sudden it moves in the opposite direction, and they don't understand even their assumptions anymore. That's why for SEP and those companies that first went through it, it was like the light bulb going off when they did this regression. It's like, oh my gosh, that explains so much of what we didn't understand before about our energy profile. So here's an intensity of kilowatt hours per kilogram of output. Rocking along pretty good July through March. It's actually trending down, and then we have a little uptick, and then whoa, what happened? Did the plant do something that made them less efficient? What do you think? Just because it turned up? What does that mean? Right. So with intensity, you've got a numerator and a denominator, right? So maybe they got overbuilt back here and had to slow down. Well, all that base load now is distributed over a smaller production base in these couple of months. Maybe it's explainable. What the standard would want you to do is understand why it happened. It doesn't mean that it's bad that it did happen, but you should understand what's driving that. So there are a lot of things that impact energy performance. Commercial buildings, occupancy. We talked a lot about other relevant variables. Weather, production throughputs. So you saw this, I think these probably these exact graphs that Deanna showed you for the relationship between heating degree days and natural gas load for a heating situation. And I will say, when I start working with a company and I first have the data, I'll do some XY plots of like production of gas or production of electricity, production different, and the weather. You know, when you get the heating degree days, do this XY plot and see what it looks like. Or just do these plots across chronological plots and then put them next to each other. Look at that. Those are helpful tools for the CP in trying to understand the situation. So in the regression world, if you can remember back to, I had algebra in 8th grade. This was introduced, that a straight line has the form y equals mx plus b. And we're just trying to develop, we recognize that the energy relationship between these variables may be a very complex thing on a curve, but if I pick a small window, I can estimate a curve with a straight line. So in this window that we pick, we're trying to get a linear being on a straight line regression for our energy consumption. Energy consumption is y. The variables, the quantities of variables are the value x, and their factor or their coefficient is m, and then the constant or the base load is b. So this helps us understand for every change in x, how much of an impact we can expect in y, right? And if x is removed, then what would I expect that to be? And there's a lot of interesting energy improvement that goes on from base load analysis. It's not done with linear regression. What they'll do is look at the weekend versus the week. Yeah, the weekend is 50% of the week, but nobody's here. Oh yeah, because we left all the air compressors and the chillers and all the support equipment running. Oh, let's turn that off on the weekend. So looking at, full load versus no load kinds of scenarios can give an energy manager a lot of tools for improving things. You don't have to spend any money to do that kind of stuff. So the equation y equals mx plus b would be a straight line like through these data points. The b represents where that line would cross the y-axis, where x is 0. And so it's also a representative of the base load for that, that regression model. So in SCP, what we're trying to develop is an appropriate model that has the right factors included. So we might have M1, X1, M2, X2, M3, X3, these different factors. And these impact energy consumption as a function of these. This is probably my advice as a CP. Just complicating the model doesn't give you a better model. It will give you better R-squares. In the end, the performance verifier asks, does this model make sense? So Deanne talked about SAT scores with chocolate. You can prove a statistical relationship between unrelated events and variables. There's sometimes a coincidence that things have the same, they follow each other in some way. But that doesn't mean that they're appropriate. So the story I like to tell is about the GM Tech Service Center. They couldn't figure out, the dealer couldn't figure out how to solve this problem because the complaint was every time the guy bought chocolate ice cream at Baskin Robbins, his car wouldn't start. But there was a statistically valid relationship between his purchase of chocolate ice cream and his car not starting. And when GM finally looked into it, in the days of carburetors, and we had to worry about vapor lock, the chocolate ice cream took longer to get because there were more servers trying to dip from the one single tub of chocolate ice cream. So it took another minute or minute and a half to get chocolate ice cream. If you wanted some other flavor, you got served faster. And that extra time was enough time for his carburetor to heat up and vapor lock by the time he got back to the car. So the PV will ask, why does this variable make sense to you? Why did you include it in the model? You can't just throw it in there because you say my R-squared went up or my p-value was good. You need to be able to defend it based on its logic and its use for your operations.
So we're not using linear regression to fit data.
Right.
We're using explain
The relationship.
variation.
So I guess the point is, even though there are some variables, statistically they are kind of relevant, but it does not mean that we need to include them.
If it doesn't help you explain the energy consumption or the variation in the energy, it shouldn't be in there. It's like the chocolate with the statistical connection to SAT or ACT scores. Yes, they are emotionally challenged when they take that exam. There is a reason they eat more chocolate or more junk food when they're emotionally challenged. Has nothing to do with their scores.
But wouldn't be like a straight, a perfect fitting statistic curve with the variable that with the variable that can't be explained, kind of like implies there's something in the process that we don't know that we need to explore as well.
Well, I'll show you when we get to the model, the way I interpret the results and when they tell me that I'm missing the variable. Or that, you know, I have a good model, but how do I know that's enough or there's not something else? Most of the time for SEP, you have a good model, but I can tell you that most of the ones I've seen, they still there's probably another variable out there that if they could find it, would improve both the model and its evaluation of your performance. So we need to give you guys a break. And I think our next slide is an exercise. But there is, I think you have a, yeah, there is in that flash drive I gave you, there's a spreadsheet called Exercise 6 Data. So if you're familiar with or comfortable with Excel, this will be easier to do this exercise just electronically. And we'll look at it. The data should look like that. So it's already kind of set up. You know, you got the headings, you have to make the conversion. So I will say for the exam, you do need to be comfortable with how to get from a kilowatt hour of site consumption to an MMBTU at source calculation. What does that conversion look like? And then, you know, do the total. And yeah, so you have production, you have electricity kilowatt hours, you have natural gas MMBTUs. You'll get total energy, but then it's asking, exercise is asking for each month, well, we really give you the steps right here. You're going to do the intensity. Do the calculation of intensity. So you'll take the total production for the year, the total energy for the year, and divide those out in MMBTUs per ton. But then plot the total energy against the production in an XY chart. And if you know how to do a trend line through the data points in Excel. We're going to do this, and then this won't go through 0, 0. I'll let you wrestle with that, and we'll look at it as a next read. And then answer these questions from your work. So I'll give you a little bit of time to work on this. Let's just take the break. And if you want to go grab a fresh cup of coffee and a snack. Let's see. We had you guys. Let's just keep the same teams for right now that we had in the first exercise. This will take a little more time.
Quick question. For the SEMPI, So like I see UPS must be currently using the energy.
Right.
So for the I.
You take production, I got 720,000, 557. Did everybody get this for total MMBTUs?
Yeah.
2,008,000.
Yes.
So divide this total energy by this tons, and you should get 2.787 or 2.9, depending on your round. So if that's their intensity for 2009, and that's how they evaluate their energy performance, what do they understand from that about their base load? What is the base load in that? If I was to plot that line, y equals mx plus b,
Yeah, the assumption is that.
there is no base load in a simple intensity.
Yep.
So, yeah, we kind of change that to
Yeah.
the regression model.
So how much energy did you forecast for 40,000 tons of production? You get close to that, 111?
Oh,
I think,
That was question 3.
oh yeah, I guess we again use the regression model to forecast that. We use that.
so intensity is a favorite of many organizations because it's simple and easy to understand.
And if you're never mentally extending it all the way to zero, it makes sense at that level.
It does, and it's easy for people to get their heads around.
Right.
Um,
It's easy for accountants to calculate.
Easy for people to calculate. It has some advantages, okay? So don't discount it, especially for an ENPI. For an ENPI, it can be a very valuable tool. But it doesn't give you, from a systems management perspective, it doesn't give you a good management tool. It gives you a good indicator, but not a good management. And one of the key reasons is that base load.
So then the last instruction was to draw a line through the origin that has a slope equal to our intensity. And this chart doesn't have, if you plot this line, it comes, down here like this. If you do regression on these data points, this is our intensity, it goes through the origin. Wish I could show the graphs you have, but when you're looking at it, you can see really the offset down here is what we would expect to that actual base load to be that or maybe higher.
Yeah, if you don't think about that, you just do this, and admittedly it's not assuming it. It doesn't look bad.
No.
It's not right.
Well, then it's not wrong necessarily. The important thing is that you understand what it's telling you, what it's not. And that's what we want people to do. Energy management is, it's okay to use it, just understand what it's telling you,
Yeah.
So it's just about time for lunch. And I hadn't told Deanne, but I got a webinar with Ingersoll Rand in Mexico at 11:30. So I won't be going, I'll be staying. Be pulling a Jennifer on us today.
Oh.
She approves of you doing that, Barry.
Let's get through these slides. There's another exercise, and we got a full afternoon. And I will tell you this, when you were working on the first exercise this morning, I was successful at installing the ENPI tool on this workstation. So I thought, for those of you that, like you were,
I've been told I should be able to do it.
well,
They
you
gave
can
me
try
a-
it on yours. If not,
Yes.
like,
Thank you.
it will not install on yours.
Oh.
Yeah,
Oh,
I
'cause-
have another PC. in mind.
Okay.
Oh.
Well,
Wow, came ready.
I'll have to install it on this one. If I have time at lunch, maybe I'll just install it ahead of time. Does everybody have it installed on their PC?
Yeah, I
Not
did.
yet,
I did.
supposedly.
Okay. Well, maybe in the lunchtime,
Yeah.
Yeah.
we can let you, so we don't have to use the time for that.
They sent me a passport, so it should literally take me 2 minutes.
So we talked about performance indicators, but really rolled up in that is what our evaluation of that indicator tells us and against what we are comparing. The baseline really becomes our basis for analysis. For 50,000, the ENPIs and their baselines are defined by the organization. So a lot of times corporate gives them a mandate, you know, we're gonna have a 20% reduction in the next 5 years. So the baseline becomes last year or this year. At the Marine Air Station, they had executive orders, they had Department of Defense directives, they had mandates from Congress, they had all kinds of baselines. You're gonna be 20% less in 2015 than you were in 2008. They have a new one that starts at 15 and goes to 2025. But all of that, you know, you can't measure your progress if you don't put a stick in the sand and say, this is how we're going to evaluate our forward motion. And that's all a baseline is. So here's, you know, we evaluate our performance, maybe production versus energy. We get linear regression, we look at that, we come back at a later date and do the same analysis, and lo and behold, the line is shifted. That represents an improvement in energy performance. If I had this red line and no black line, how could I say, how would I know? So we'll talk about this when we go through the M&D and the adjustment methodologies, but it really does, the SCP does answer this question. If we had not done the things that we've done, what would our energy impact? What would our energy performance have been? But baselines can also not just be chronological. They might be based on industry standards or industry groups. There's, you know, a benchmark maybe within a specific industry for attaining some performance level, you know.
Randy, have you found that, specifically the chronological though, that companies tend to use calendar year or fiscal year? I'm asking specifically for the Nissans. I know what their fiscal year is. And but we're taking into consideration some of the simpler tools we're creating, it's got to be calendar year. I wonder.
Most of the ones I work with do not use a calendar.
Yeah.
That's what I wanted to know.
Well, even for SCP, you know, you're flexible in when and how you model. And you don't have to be, even if you're using calendar years for your performance evaluation, you can model a different time frame in the middle if you're changing. That's a whole other discussion. For SCP, I don't know, I'd say maybe as often it's not calendar years it is because other events create milestones that they either want to include or work around.
Well,
So I know like Nissan had to shift because the gas supplier couldn't supply 2 months of data. And it was easier just to get on the other side of that anomaly and say, we're going to start it in March or April and go through the next March or February.
Well, I throw out the hypothetical that we might have a company that wants to look at essentially, in the automotive case, a time period that starts when they start a new model.
Their model year, yeah.
On a production line. And so they'd like to check the year after that. And I just wanted to know if that's fairly common.
Yeah, I would say it is fairly common. We have to think about a new baseline or making adjustments when we have changes, right? It's not, let's say that you're powder coating a steel part, which has more mass per unit, takes longer to heat up and cure in a powder coating oven, and now we switch to aluminum. before I switch to a plastic part that doesn't have to be powder coated. Now my process looks different. Is that a process improvement, or should I adjust the baseline so that I'm comparing this production with this, with the right, am I making the right analysis? Am I making the right comparison? We have to do some of that for SCP, but you should also do it across all the ENPIs in your management system. Have things changed, and are we doing the right analysis? Well, is the ENPI appropriate, and is the baseline the correct baseline we should be using for that performance indicator? So anytime those changes we talked about in the energy review, those are the same kinds of changes that trigger us to ask, how do we evaluate performance, and how do we know? So it's 10 minutes to lunch. We can go maybe a couple minutes early. We're going to build on what we just did. So I don't think. Yeah, so there's another spreadsheet called Exercise 7 data, and it has 2011, same. You're going to do basically the same kind of analysis. We don't have to, I don't think, do as much charting. I can't remember the specifics. So just two questions. You're going to do that intensity, compare 2011 to 2009. This is typical of how industry would do their energy analysis before they got into the management system. And it's okay to do it after. I mean, this is appropriate for 50,001, but it's also helping you understand why SCP is a more robust measure of performance. And then tell me have they had an improvement in intensity? What is it? So you can work on that for the next 4 or 5 minutes, and then we'll head to lunch, finish this up.